In today's tutorials, we are going to introduce you the integration. So in part 1, the anti-differentiation. Before we go into the integration, we have to revise ourselves about the anti-differentiation, or what we call the derivative. For example, if we have a function x to the power n, and its derivative will be n x to the power n minus 1. And if the function is e to the power x, its derivative will be e to the power x. So let's go through this table and try to remember as much as you can. Now we go to the integration, or what we call the antiderivative. We have a new symbol here. We can write the antiderivative or the integration by this symbol and with respect to x. In the middle is some function x. This is the integration of it. We assume that you are familiar with the following elementary function: the polynomial function, power of x function, the trigonometric function, sine, cosine, tangent, secant, and etc., the exponential function e to the power something, and also the natural log function, and are able to differentiate between these functions. We also assume that you can recognize the composite function and are familiar with the chain rule for differentiating them. In addition, you need to know some simple trigonometry identity. For example, sine square x plus cosine square x is equal to 1, based on the definition of tangent, cotangent, secant, cosecant, sine, and cosine, and also the Pythagoras theorem. Finally, the knowledge of the inverse trigonometry function, inverse sine x, inverse cosine x, or inverse tangent x, and their derivatives would be a help, but it is not essential. If we just refer to the table, so the derivatives of inverse function sine x is equal to 1 over square root 1 minus x squared, etc. Okay, now check on your knowledge about the differentiation of some function. If you have a function y equal to fx, some function of x equal to x to the power 10, and the derivative of y respect to x, you can write y dash, or you can write it dy by dx, is also the derivative of function x is equal to, you take this 10 power down, 10x, and the power of x is minus 1, so you have 9. This is the answer here. Okay, you can go through these 3 examples here to test your knowledge about the differentiation. And also the derivative of this function, I take one function here, so y equal to cosine x to the power 3, so the derivative of y is equal y dash equal to, and cosine is changed to minus sine x to the power 3, and also derivative of the inside, you have 3x squared. So the answer would be minus 3x squared sine x to the power of 3 minus 3x squared sine to the power of x3. And now we go to page 5, the definition of integrals as an antiderivative. So if you have a derivative of a function capital Fx is equal to some function f of x, small f, and if you take the integrals of fx respect to x, you get back the capital letter fx. And in some case, for example, if you have x squared and you take the derivative of x squared, you got 2x, and then you integrals of 2x, you get back x squared. But this is a general solution, because when you have another function, let's say x squared plus 10, and if you take the derivative of it respect to x, so you have the 2x as well. So we take the integration of 2x, you get back x squared. But how about this plus 10? This should be plus c here. C is a constant. So you got a very important function. Integrals of 2x respect to x is equal to x squared, and don't forget the plus c. This constant, what we call, is arbitrary constant. Now try some example. For example, if you take the derivative of x to the power of 5, you got 5 to the x to the power of 4. And if you integrate 5 to x to the power of 4, you have x to the power of 5, and don't forget plus c. C is a constant. So you can go through this exercise and check your answer on Google or YouTube. Also, this exercise as well, I just do one question for you. Let's say we do the question 5, integrations of 2/3 x to the power of 1 over 2 dx. And now we can write 3 over 2 here, and the integrations of half x, we can get 3 over 2, and we multiply by 2 over 3. And don't forget the plus c. So we have the answer here is this one cancel out, this one cancel out, and we have x to the power of 3 over 2 per c. If you want to check the answer, you can do another way round, is take the derivative of this function. So if we take the derivative of x to the power of 3 over 2 per c respect to x, we have this 3 over 2 put down, we get 3 over 2 x, and this minus 1 is 2/2. We get back the original function here. So the answer is checked. In the next tutorial, I will show you some rules for the calculating the integration of a function. So after the break, we go through some rules of calculating the integration. We have some constant c, and we want to integrate c fx respect to dx. We can take out this constant outside the integration, so we have c, the integration of fx dx. First rule of the integration. Now take the examples. If we want to integrate tan cosine x dx, we have tan outside, and then we integrate the cosine x of dx. What is the integration of cosine x of dx? It is sine x. And don't forget the per c constant. After finish the first rule, we go to the second rule. In the second rule, if we want to integrate two functions, fx plus another function gx with respect to dx, we can break down this into two integrations. The first integration of fx respect to dx plus the second integration of gx respect to x. Now we go to some examples of the first and the second rule. If we want to integrate 1 plus 2x minus 3x squared plus sine x respect to dx, we have the integrations of 1 dx plus 2x dx minus 3 integrations of x squared dx plus the integrations of sine of x dx. And then this is equal to x, and then this is equal to 2x squared over 2 minus 3x to the power of 3 over 3 plus sine is equal to minus cosine x, and then don't forget the per c constant. So we have x plus x squared minus x to the power of 3 minus cosine x per c. We check the solution up here. So you can do this exercise by yourself and check the solution in here. Okay, I got 4 exercise for you. I pick up the question number 3. I have the integrations of 1 minus 10x plus 9x squared dx. I can do it as the 1 goes, 1 is equal to x, and minus 10x is equal to minus 10x squared over 2, and 9x squared is equal to 9x to the power of 3 over 3, and then plus c. And now you got x minus 5x squared plus 3x to the power of 3 plus c. If you want to check this answer, you can also differentiate this. Let's see if you get back the original function. So you take the differentiation of x minus 5x squared plus 3x to the power of 3 plus c, and differentiate with respect to x. You got x is equal to 1, and minus 5x squared, you got to minus 5. This one is equal to x, and you multiply by 2, and also plus you multiply by 3, and x3 is equal to x2 plus c is equal to 0. So you get 1 minus 10x plus 9x squared. And is this the original function? You just check back here. And now we go to another topic, the integrating power of x and other elementary functions. We can now work out how to integrate any powers of x by looking at the corresponding rule. This rule is that we integrate n x to the n minus 1, we got xn plus c. So the most important integration you have to remember is the integration of x to the power n dx is equal to x to the power n plus 1 over to n plus 1, and don't forget the per c. This is what you want to remember. And now just do some exercise, and this one is the question 3. If you want to integrate square root x dx, it is similar to integration of x to the power half dx. When you take the integration, you make the powers one more. So you get x to the power of 3 over 2, and then you divide by 3 over 2. That means you multiply by 2 over 3. And then don't forget the per c. So you have 2x to the powers of 3 over 2 over 3 per c. This is the answer in here. So just do the exercise 1 and 2 and check the answer by yourself. And now we have some exercise for you. We have the exercise 1, 2, 3, 4, 5, 6, 7. Just do it by yourself and check the answers on Google, YouTube, or even on ChatGPT. Find the following undefined integrals. I just pick up one question. The first question, if you want to integrals of e to the power x plus 3x to the power 5 over 2 with respect to dx. And then e to the power x, the integration should be the same, e to the power x. And then for this one, you put 3x to the power 5 over 2 should be go to x to the power 7 over 2 and multiply by 2 over 7. And don't forget the plus c, so it's equal to e to the power x plus 6 over 7 x to the power 7 over 2. And this should be the answer for the first question. So for the second question, you try to do it yourself and check your answer here. In this topic, I will tell you some things you can't do with the integrals. For example, if you have integration of x multiplied by x, you cannot just take out one x here and integrate the x inside. This two things is not equal. So remember, if something is x respected, you cannot take out this function outside. And the second you don't do is that if you have integration of x multiplied by functions of x dx, it is not equal to x integrations of function of x. Let's see some mistake underneath. If you want to integrate the function x squared plus 2x and multiply by x dx, it is not equal to x integration of x squared plus 2x dx. These two things is not equal. And then the first thing you don't do is that if you want to integrate two functions fx and gx multiplication respect to x, you just take out one function fx and just integrate the function gx. This is not equal, and this thing is wrong. So remember something you don't do in these three examples. Now you're using the change rule in reverse. You have already seen the change rules in the differentiation, and then if for the integration you want to do the change rule in the reverse order. This is the definition of the change rule. This one is very important. If you have dy by dx, this is equal to dy by du multiplied by du by dx. For example, if you have size 3x and if you differentiation size 3x, you got cosine 3x multiplied by 3. So now if you want to integrate 3 cosine 3x by dx, what you have to do is that you let u equal to 3x, and then du is equal to 3 dx, and then dx is equal to du over 3. So this integration can be rewritten into integrations of cosine 3x is cosine u, because u is equal to 3x, so you got cosine u. And dx is equal to du over 3, so you got du over 3. These two 3 cancel out. You only get integrations of cosine u du. And the answer will be sine u per c. What is u? U is 3x, right? So you have the answer sine of 3x per c. This is the original function, sine of 3x per c. C is some constant. So this is the inverse of change rule. Now we do some exercise about this change rule. If you want to integrate sine 3x multiplied by cosine x. Now you just let u equal to sine x, and then du is equal to cosine dx. That means dx is equal to du over cosine x. And then you substitute this function here. You got integrals of sine x to the power of 3. That means you have the integrals of u to the power of 3. And then cosine x dx is du, right? So you write du. And then the answer will be u to the power of 4 over 4 per c. And what is u? In this case, u is sine x. So you have sine to the power of 4x over 4 per c. This is the answer. 1 over 4 sine 4x per c. This is how you apply the substitution and solve this integral function. In here for the exercise 7.2, I have some exercise for you, and you can do the exercise by yourself and check the answer on YouTube, Google, or even ChatGPT. Now we come to the hardest one, is the applications of the integration. The application of the anti-differentiation or the integration arise in problem in which we know the rate of change of some function and we want to find the function itself. The problem about the motion provides many examples, such as those in which the velocity, if you know that the velocity of something is equal to the rate change of the displacement. For example, 80 meters per second, this is the rate change. Since velocity is the rate of change of the displacement, we must anti-differentiate, we must integrate to find the displacement. And now I give you simple example. If a stone is thrown upward on the top of a tower 50 meter high, so you draw the tower and the height here is h equal to 50 meter. And this is a stone fall upward. Its velocity in an upward direction t seconds later should be 20 minus 5t meter per second. That means the velocity is equal to the ds by dt is equal to 20 minus 5t. Find the height of the stone above the ground 3 seconds later. That means when t is equal to 3, you want to find the height of the stone above the ground. So let the height of the stone above the ground's level as the type t is h. This means it's h. We are given two pieces of information in this problem. The first one is the fact that the tower is 50 meters high. Tell us that when t is equal 0, that is as the moment of the stone leaves the forward hand, h is equal to 50. And the fact that the velocity as type t is 20 minus 5t tell us that the velocity, the differentiation of dh by dt is equal to 20 minus 5t. Now we begin with the second statement, which tells about the rate of change of a function by anti-differentiation about it. We want to take the integration of this with respect to dt. We get the function of h. So we integrating this, we got the function of h is equal to 20t minus 5 over 2t squared per c. Now it is virtually important not to forget the constant c. But how to calculate this constant c? We have the initial condition. What is meant by the initial condition? The question given that when t is equal to 0, h is equal to 50, right? So we substitute h is equal to 50 in here, and t is equal to 0. This one cancel out. We got c is equal to 50. We substitute c is equal to 50 into this original equation. We got this equation of h. And now let's go back to the problem and read it again to check exactly what we are asked to find. What we are asked to find is that 3 seconds later, the displacement of the stone, how high is above the ground. So we substitute t equal to 3 into this equation. We got 20 multiplied by 3 minus 5 over 2, 3 to the square plus 50. This is equal to 87.5. So h is equal to 87.5. And what is the unit? The unit should be meter. Okay, we have solved the question, but now let us look back at the structure of this problem and its solution. We are given the information about the rate of change of a quantity, and we anti-differentiation, we integrate to get the general expression for the quantity, including the arbitrary constant c. How to get the constant c? We have to use the initial condition. And the initial condition in this question is when t is equal 0, h is equal 50. We use this initial condition, we can calculate the value of c. In this case, is equal to 50, right? And we now have a precise expression of the quantity and can use that to answer the question. Now go to another example. The example is that a population of animals under certain conditions has a growth rate of this. So the growth rate, that means d of the population, let's say p by dt is equal to 500 pi cosine of 2 pi t. And the t is in year unit. If the initial size of the population of the herd, initial size, that means when t is equal 0, the p is equal 3000. This is the initial condition. Find the size of the population as type t. That means we have to find the p function. What are the maximum and the minimum maximum number in the hertz. First of all, we have to integrate the dp by dt respect to t. Integrations of 500 pi cosine 2 pi t respect to t. And here we use the substitution. We let u equal to 2 pi t. du by dt is equal to 2 pi. So dt is equal to du over 2 pi. We substitute this into here. We got 500 pi. Integrate cosine of this one. So it's cosine of u. And dt is equal to this over 2 pi. And we cancel out the pi. And also 500 into 250. So it's equal to 250 integration of cosine u by du. So we have is 250. The cosine will be go to sine u per c. And then the solution is 250 sine. What is u? U is 2 pi t, right? 2 pi t and per c. So how to calculate the value of c? When the time is 0, the population is 3000. We substitute into this equation. So 3000 is equal to 250 psi when t is 0. 2 pi multiplied by 0 per c. 2 pi psi 0 is 0. So we have 3000 equal to c. So the general solution should be 250 psi 2 pi t per 3000. So what is the maximum of or minimums of this function? Now we calculate the maximum and the minimum population. Now we calculate the maximum and the minimum population. The population equation is equal to this. This 3000 is never changed. And this one, psi 2 pi t, the maximum value should be 1. So it's 3000 plus 250. So the maximum population should be 3250. And the minimum population, this one is go to minus 1. So it's minus 250 plus 3000. So it's equal to 2750. This is the minimum population and the maximum population of the herd. This one you can do maximum and the minimum. Okay, this tutorial is stopping now. I hope you enjoy my tutorials. If you like this tutorial, give me a like, subscribe, and watch my channel. More about the techniques of integrations in the next tutorial. So stay tuned and wait for my next tutorial. Good luck and goodbye. Adios, hasta la vista.